In this video we are going to make a distribution box with 4 outlets. It will have some interesting features including power meter, over voltage, under voltage protection and fault protection. I have made some schematics that you can see it here. It is a simple guide how to make this box with 4 sockets. This is a global preview of front of distribution box, how it will look like when it is all done. Now we have a simple one-way schematics. I have added maybe more lines than there is a need for it in order to be simpler to understand. In upper part of schematics we have our power line from where we will take our phase, and from there go to our RCBO. This RCBO has overcurrent and fault protection. Overcurrent protection is 16 amps and fault protection is rated at 30 milliamps. Then we will go to our under voltage, over voltage protection device. Then we will have one line going to our power meter, and from there we will have our phase going to 4 sockets outlets that we will use in order to make this box work. Now we have our power meter from where we will get information about power usage in our outlets. As you can see, we have 4 sockets, DIN standard sockets. This is standard Schuko socket. It is used in Europe mostly. It can vary from country to country. In France it is different, in UK different, in USA it is also different, so you can choose the one you find fit for your country. I will use 4 of them to mount them in accordance with this one-way point schematics I made. This device, it will be used from 5 to 40 degrees Celsius. Now we have a hot summer, so I think 40 degrees is kind of a normal temperature to be provided for anyone making distribution boxes of any kind. I also prepared this sticker to put it on housing when we finish all the job. Also, there will be some other parts I will use to complete this task, including this bus bar terminal. It will help me to collect all my phases into one. I will use this for output. I will put some cable that will go out from this distribution box into socket. We will of course use different types of wires, terminals, and main thing is this distribution box that will be used to put all these devices inside, and at the end we will test it to see if it works with this simple device. Of course, there is a various different tools we will use to mount all this, test it. I will talk about tools more if there is a need while working with them. So different screwdrivers, pliers will be used in order to make this complete. In order to have a power cable connected to this distribution box, you will need to drill some hole with this standard PG11 connector. I will drill a hole from this side here. You can drill a hole in some other places if you need it. For drilling I am using standard wood drill to start the process. Why wood drill? Because wood drill have a center tap and with a center tap you can easily start a hole. You will need some other drill later in order to get a proper hole, but for start I will start the drilling process. Somewhere here in the lower portion of this plastic distribution box. You can measure center or where you need. As you can see, now I am going to change a wood drill bit for a step drill bit in order to get a bigger hole. So we will need about 16 millimeters. Yes, it is 16 millimeters. So we'll drill until this step and then we will stop. Let's see. Maybe we need one more step. Okay, now that we have a box prepared for montage, we can put our modules on it in order to see shape and also determine cables, lengths and positions. We have 4 sockets. As I said before, it is DIN Schuko sockets. It is according to German Schuko DIN standard. They will be placed here. We also have a power meter module that will be placed here, under voltage, over voltage protection module, and also our main switch that is in same time our fault protection module. So we can enter our cable here. This is our power cable. It will go up here, something like this. Okay. Phase and neutral will go here, and our earth terminal should get here. Let's see if this is enough length. Maybe I need to cut a little bit more from this protective shot here. Okay. This is it. Let's see this length. Okay. So this is start. When you measure this, just imagine an angle. You can also use a meter in order to have a more precise measure of cable lengths. When you are making a terminal, you always need to get the copper on side of terminal. I don't know if you can see it. Let's try it on this. So when you press it down, copper needs to come to this end. So now let's provide fields for our sockets. We'll need 4. We will need, I move this wire from upper side to bottom side and use this plastic screw holder to fix this external current transformer, and as you can see, I will put this here. Maybe I need to lower the length of this cable a bit. Also we need one more wire here in order to power this power meter. I will use also this spiral protective sheet in order to a little bit put all these phase wires in some protection. Skip this time. Try to finish first this. So a moment of truth has come by. We can now try to see if this works. It is now time to start this device. We will use our RCBO, who is our main switch, to power up device, and in same time it is our fault protection device that measures a differential current between neutral and phase, and if there is any fault it will protect us. This is our main switch. Let's try it. Okay, this is some kind of initialization. Yes. So we see it starts initialization, and if it thinks it is all okay, then it starts to giving us output. As we can see here, we have 229 volts, and on our power measuring device we have 230.4 volts. So there is some small difference between these two devices and measuring of voltage. Let's see with this simple Parkside device what it tells us. As you can see, it thinks we should reverse sides, but as I already told you, there is no real standard for these Shuku devices where phase should be. It could be left, it could be right. I put all phases left. As I explained, children likes to play, and the first things they do, they touch right side. So you always put the phase on left. Okay, all sockets will show us the same result. Let's try to trip device. You cannot trip it. Why? Because of reverse. But if we reverse this tester, as you can see now, it is okay. So this Shuko doesn't know the side you put of your cable into outlet, so it is easy to reverse, and as you can see now it works. So do not be confused, because it can have phase on left side, on right side, and you can also reverse this socket when you put into outlet. It can be on two ways. Okay, we have initialization here again, and main thing is it is working. Okay, tripping, okay. Now we are going to test these power sockets with some consumer attached. Okay, we have initialization completed, power meter turn on. Let's see when we turn on the consumer. We will now measure real current output with this professional measuring device clamp meter and compare results from clamp meter with these two devices we have integrated in our distribution box. I will turn on power kettler, water kettler, so let's see. Okay, we see there is about 1.5 amp difference between amp meter and these two devices. They are practically showing the same current, 8 amps, and here we have 7.44 amps. Okay, let's try through this conduit, because this conduit used by this power meter. We can see also nice difference, about 0.6 amps difference between this amp measurement device and these two devices. So for better accuracy we need to use something like this. Of course, these power meters could give us some general information, but accuracy, as you can see, is not very well, and for standpoint of accuracy, this tool would be unacceptable. We cannot rely on these two devices to show us real current usage, but we can use them to have some sense and general information about current usages. Okay, let's try one more device. Let's compare. As you can see, there is a difference between current clamp and these two modules in showing current usage, and we can see that these two modules are not accurate enough to measure current with this power usage. So let's close this device. Okay, that's it. Now it is in protected closing. Let's see how it works. Okay, initialization is over, power meter is on. That's it, very simple. 4 output device with power measurement, over voltage, over current protection, fault protection, easy to use. This is IP55 housing, but in same time you should be aware that it is not appropriate to put it in rain. As we saw before, power measurement and current measurement from these two modules devices that we're using in this distribution box is not perfect. It is not accurate enough to be used per se, but it will provide us with general information about power usage of any outlets and consumers attached to it. We saw when we have higher current, the bigger error it is. On lower current, small error, it is about 5%, give or take. So for standpoint of accuracy, you cannot rely on it. But for standpoint of about basic information, you can use it. And of course, you can always compare this result with some better accuracy device. I hope you like this video, and for future videos please subscribe on my channel. Thank you for watching.